Theoretical recap. Problem decomposition is one of the most fundamental skills a developer must internalize. It consists of taking a complex, vague, or large problem and systematically breaking it down into smaller, independent, and manageable subproblems. Each subproblem should be simple enough to be solved in isolation before being reassembled into a coherent whole. This is the foundation of algorithmic thinking, and it applies to every line of code you will ever write. A common mistake beginners make is trying to solve everything at once, jumping straight into writing code without understanding what the problem actually requires. This leads to confusion, bugs, and wasted time. The correct mental model is: understand first, decompose second, then solve step by step. Think of it like building with Lego bricks. You identify the pieces you need before you start assembling anything. A mini example: if the problem is send an email, you can decompose it into 1. Open an email client, 2. Click compose, 3. Fill in the recipient field, 4. Write a subject, 5. Write the body, 6. Click send. Each step is atomic and clear. Notice that even this simple action has an order, dependencies, and conditions. What if there is no internet connection? Common mistakes to avoid: skipping steps because they seem obvious, not considering error cases, and mixing the what, the goal, with the how, the implementation. Workshop brief. In this workshop, you will apply the developer mindset, specifically the skill of problem decomposition, to a concrete, everyday situation: ordering a pizza online. The goal is not to write any code. Instead, you will practice thinking like a developer by analyzing a real-world process, identifying its components, sequencing them logically, and anticipating edge cases and potential failures. This exercise directly mirrors what you will do every day as a full-stack developer when you receive a feature request or a bug report. Your task is to produce a complete written decomposition of the ordering a pizza online process. You must approach this as if you were a developer who has been asked to build an online pizza ordering system from scratch. You do not know yet how to code it, but you need to map out exactly what the system must do, step by step, from the user's first interaction to the pizza being delivered. Start by identifying the main actors involved in the process. Who interacts with this system? Think beyond just the customer. Consider the restaurant, the delivery person, and any automated systems, payment, notifications, etc. Write down each actor and their role clearly. Next, break down the full ordering flow into sequential steps. Begin from the moment the user opens the website and end when the pizza arrives at their door or the order is canceled. Be exhaustive. A step like the user pays is too vague. You need to break it down further. What information is required? What happens if the payment fails? What confirmation is given? And so on. Aim for at least 15 to 20 distinct, atomic steps. For each key step, identify at least one possible failure scenario or edge case. For example, what happens if the selected pizza is out of stock? What if the user enters an invalid address? What if the payment is declined? This part of the exercise trains you to think defensively, a critical habit in software development. Document these failure cases alongside their corresponding steps. Finally, write a short reflection, 10 to 15 sentences, on what this exercise revealed to you. What surprised you about the complexity of a seemingly simple everyday action? Which parts felt hardest to decompose? How do you think this skill will apply when you start writing actual code? Be honest and analytical. This reflection is as important as the decomposition itself. Your deliverable is a single structured document, plain text, markdown, or a simple text file, containing the list of actors and their roles, the ordered list of atomic steps, the failure cases per step, and your written reflection. There is no single correct answer, but your decomposition will be evaluated on its logical coherence, exhaustiveness, and the quality of your reasoning.